Mm, so you discussed about inheritance, right? How to, based on your requirement, how do you want to store the data in the database for table per class, table per subclass, table per concrete class, right? And association, we need to see one to many, how to establish a one to many relationship. In this table, as of now, how the single table can be, how your object can be represented in the database using inheritance, right? Like, if you have this car and BMW relationship or payment types relationship, how are we going to represent? So Hibernate provides you a couple of options. You can represent as a table per class option, table per subclass option, table per concrete class option. So these are the three different options it shows you. But there is another interesting challenge that you may have is how do you want to represent one to many relationships? Like there are two tables, like student and employer, student and faculty relationship. How do you want to represent between the relationship between the faculty and student? How do you want to one here, like a student versus faculty is like, you can say simply, like, it's a many to many, right? One student can be enrolled into multiple faculty sessions, multiple faculty courses, and one faculty can be teaching more than one student. So there is always many to many relationship. So how do you want to represent in the database point of view? How can we make use of Hibernate to represent these relations, right? That is where association comes into picture. So how do you represent many to one to many? So in this case, I am taking an example of a product, and a product is going to have multiple parts, right? Product is going to have multiple parts. So how do we represent this product and parts in the database? Let me show it. Okay. EH caching we need to do. So let me create a package first. Create a cache class in the package, so cache is com dot bell info dot hibernate dot. Oh, sorry, thank you. Hibernate dot association. So we'll take a representation for product, and a product can have multiple parts, right? This is the example that Hibernate also trying to explain using example. So I thought like this is the best one to. So private int product ID will be there, right? Whatever the product ID we have. Then product name private string name, and then parts will be there. So product and parts are we have a product. A product can have multiple parts, right? in this product, if you look at, right, there will be different parts. In order to prepare the product, you may have multiple parts. You may need multiple parts, right? With all these parts only, it will become a product. So let's say, what do you call it? Desktop, what do you call desktop, right? A desktop is going to have, let's say, computer setup. You can say computer setup is a product kind of thing. Okay, so I'm going to say I need a desktop, I need a table, I need a keyboard, I need a mouse, I need a light around, and I need a vertical charger. So with all these parts, you will make a desktop setup as a product, right? Even in your laptop, a simple laptop can be represented into different parts. Keyboard setup, when they are manufacturing your laptop, right? The screen guard, screen protector, and touch ID functionality, software, charger, HDMI, Core i7 processor, RAM, battery. So these are all the different products to make your product, right? So the relation between the product and parts is 1 to many. So that's what we're going to do. So let's write, before making and establishing a relationship, let's write the parts. What are we going to have in the parts, right? Let's call parts. Each part is going to have its own name, right? So each part is going to have its own name again. Private int part ID, private string part name, private okay, then private part int part ID string part name. Okay, so I'm going to create argument based constructor. This is this dot part ID to part ID, this dot part ID, part ID. Then public int get part ID or return part ID. Public void part ID. Let me generate it. Generating HCs, you don't need to put all efforts. Okay, part has been generated here also. Before generating, now you have a product, you have part, right? Each product is going to have multiple parts, right? Multiple parts. So if I represent here part, it will become 1 to 1. If I represent something like this, private part part, if I represent like this, right, what will happen? Each product is going to have only one product, one part. One part will make a product. A product can have one part. So that is not our goal, right? Our goal is to represent a multiple parts in a product. How do you represent multiple? It needs to trigger in your mind as a collection. So a collection, it should represent your mind or a list or set. So how do you represent? What is the best option? So for me, as I don't want to store duplicates in the parts, so when I say duplicates, immediately it needs to strike your mind. You need to go for set option. Make sense? So I'm going to have set of parts. I'm going to have a set which is going to have parts. Make sense? So now if you can put multiple parts, so in a single product you are going to have multiple parts. Okay, make sense? Okay. So next, getters and setters now. Then toast, right? Okay, nice. Now we define the our our entity objects. We going to call not it. Let's call it as our simple objects. Our objects we represented in our Java. So we need to represent these into the database. How do you represent? Using what? Using configuration. You need to convey to the Hibernate. These need to be represented into the table in this fashion, right? So let's go back to our configuration. This is where we're going to represent our product as well as, that's right. Just to save time, I'll just take one of them and copy paste, and then I will take out and start adding ours. Okay. So what I need, product, right? Okay, next. Let me copy paste one more. Part. Nice. So let me go to first simply write the part, because part is simply, a typical our object, right? Nothing fancy there. It's a simple object. So let's remove this piece. Let's remove everything. Class. Today just be patient and be focused, because we're going to discuss a lot of topics. So I don't want you guys get diverted and not to understand. Because now what we're doing, everything in the XML configuration for Hibernate, right? When we start integrating with the Spring, we'll take out everything. We are not going to configure everything. We are not going to do here. We are going to do everything in the Java, just like in the Spring, right? Earlier we used to configure everything bean ID, and then if you want to inject using setters or constructors using, so instead of that, what we started doing, instead of injecting, you are started using auto-wire, and if there is a conflict, you are using @qualifier, and if you want to write a bean ID, you are using what you call the stereotype annotations. So same thing, Spring and Hibernate comes up together. Same annotations for Hibernate tables as well. Okay. Part table, and I want a table name part Inside class what we'll have? ID, name, part ID, column, part underscore ID, for now let's see, and then property, part name, right? What we have, part name, column, part underscore name. Okay, this part name should not be null. That's what I'm doing. Okay, nice. Next one is product. We need to fill the product. Class name, table, schema, you don't need, actually by default it will take, but yeah, it's good. What is the name? Dot product. Then you need to have what? ID, name, PID, column you want is product underscore ID. For now, let's represent. We will change it later if required. I'm not going to use any sequences. Okay. Auto generations I'm not using for now. Name, column, product column, not equal to true. So this is a typical way. So now you want to represent this piece, right? How do you represent? Using, it's a set, right? So I'm going to take set name equal to parts. There is a concept called cascade. I'll explain you. Cascade equal to, there are different options. We can say all for now. Cascade option is important here. Okay. Then you need to convey what is the ID. Key, column, parts, cascade, product. You don't need to represent here cascade. You don't need one-time thing. Key column. What is the key column that you want to consider in that you're setting the parts as all, and then key column is, what is your key column is, you're going to have product ID here, product underscore product ID key, and then what is the relation you need to convey? What is the relation you need to convey? It's a one to many. My one product, I am writing in product, one to one should be the product that you know where you configuring. I am configuring in product, so one product, many parts. That's what here represent. Okay, so one to many class. All you need to provide is this fully qualified name. Between whom? That's what you are conveying. You are configuring product and whom, product and part. That's what you configured here. Yeah, that's enough. Key cascade all enough, right? Anything I forgot? Yeah, good. So now what else pending? Now you need to go back here, write a class, client class, right? How to let's say one to many client. Okay. One to many clients. So let's write last time our typical configuration, right? Configuration what? Okay, it's already there. Okay, CFG equal to new configuration dot configure. One thing we forgot, you guys should catch it up by this time. Hibernate dot CFG dot XML. So in CFG dot XML it loads, but in your CFG dot XML did you mention your configuration related product, and did you mention your what you call your parts and product configuration? No, right? So you need to do those configurations. Mapping resource one is part, another one is product. Okay, you don't need these things, right? Comment it out. Okay, nice. Where is our program? Once configuration session factory SF equal to EFG dot build session factory session. From session factory what we'll get? Session open session then transaction. From that we can get the transaction tx equal to s dot begin transaction. After that piece is done, and tx dot commit s dot close sf dot see. There are bunch of methods available in each of session, transaction and session factory, but I am using whatever required. So when you are developing some other project, you don't need to worry about, oh, this topic we haven't learned, so how do I get this piece? I explained only the ones that are required for our programs to understand. So there are bunch of other opportunity, bunch of, see, transaction dot commit, right? Transaction dot, there are bunch of the begin, transaction equals, get, local status, time, is active. These are all the different things. Based on your need, you need to use it. Covering everything is impossible in the class. Okay, keep that in mind. Part. Now we're going to create a parts, right? P1 equal to new part. Mm, new part, what happened? It's not able to identify part. Okay, so I'll say 1 comma, let's take monitor, and what is the problem with this? Oh, sorry. If you write private, how can you create, right? Then repeat it. P2, P3, keyboard, mouse. Okay, now set. You need to keep all these in a set, right? P set equal to new asset What is the problem? Set part set of parts equal to new asset then you need to start adding your parts into that, right? Set parts. I will say, yeah, parts. Let's call it as parts. Okay. Parts dot add P1. Parts dot add P2. Parts dot add P3. Okay. So now you need to pass these parts into your product, right? So create a product. Product P1 equal to new product. What and all you need to pass? ID, and then name of the product, desktop, and what are all the parts required for the desktop parts. Here also same, we called it as, oh, we haven't wrote a argument based construction. Public product, another one is public product int id comma int string name comma set part parts. Right, then this dot PID equal to ID, this dot name, this dot p name equal to name, this dot what's equal to what's. Okay, now we'll come back here. Yeah, it is taken. Okay, so you created a product object, is a product ID is one, a product name is called desktop, and the products required for the desktop is monitor, keyboard, mouse, and you are trying to save. If you save this product, your parts also will be automatically saved into the database. Let's see whether it is saving it or not. Yes, dot save. So come back here. Here you don't have a table, so I don't need to show it to you again and again. You guys know better. Now what will happen, which configuration we are using, update configuration, right? So it automatically, if the table is not there, it automatically create the table and then start inserting. And in this section you are trying to save only product, but product will carry the parts table as well. Product is going to carry the parts table. One is, how does it carries? Because in your product table you configure parts and you convey the relation between the products and product IDs using the product ID, and this is the parts table in your product configuration itself. So it's now Hibernate responsibility to take these values and create both product and part and establish the relation between those two as one to many. Okay, nice. Let's go ahead and okay, nice. Could not parse mapping document product.hibernate product.hbm.xml. Class not found while looking for product for property PID. This is PID in your product. What you represent? PID. It is the problem. Name we haven't represent here. Table name we are representing as a product. See, sometimes we do, that's right. Table name is what you want, product. Class name, table name, schema, PID, product ID, P name, product column, class parts, cascade, blah 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 blah. Okay, let me check this guy as well. Did I do the same mistake here? Product name I mentioned, very nice. Okay. Okay, let's go back and run the program. Oh, we got different ID. It's because you are giving the same product ID for all the parts. Same parts ID for all the parts. Run the program. See, we learned by our mistakes, right? Okay. Null value in column part name violates not null. Null value we are passing. Oh la la. Part name, part underscore name. With the representing with what? See, another part name we wrote here, right? What we write here? Part ID. Let me copy it. Part ID and then part name. It is not able to insert. It is going with null values.
Excuse me.
Yep.
Can you check the parts.java file part third? In that in the constructor this dot part ID is two times. This dot part name should go there.
Perfect. Perfect. Nice catch. Who is this, Srinivas?
Anvesh.
Anvesh. Oh, nice way. Awesome catch. Love it. Now let's go back. Yeah, now it's done. Let's go back and see. Part and product both are created. Let's see what and all the select star from HIV schema CHE dot product. There is a desktop, right? So there is a product ID and then product column as desktop. If you go here, select star from HIV schema dot You can see part ID as 3, 2, 1. Three different 1, 2, 3, 4. Right? Product name is there. But here if you observe, product ID has been created. 1, 1, 1. This 1 belongs to what? In your product, what it represents? Product ID represents 1. Is a desktop. If you insert again another one, right? Like, now you inserted desktop related parts. So if you want to write something else, like, simple case, mobile, right? Mobile, I'm just using two. You can use that auto generation as well, but just avoid all the complexities. What you called mouse, headphones, charger, and case. Part 4 I'm going to represent as screen protector. These are all required. Let's say my phone when I say mobile, okay? Of course mobile required, but just mobile parts. Mobile, I'll call it as accessories. Excuse me with my English. Before. So whenever somebody say give me the accessories product, mobile accessories product, I need to provide a phone, charger, case and screen protector, right? So now I'm going to save this, guys. Run the program. Okay, let's come back. So let's run Hibernate product again. So now second product is mobile accessories. What are all the products required for mobile accessories? Charger, screen protector, headphones, case. Okay. Maybe this ID should be different than what we have earlier, so that it would have been saved. It did. Now what happens is it's overridden whatever the IDs that are there, these IDs, because we haven't mentioned this ID is unique, right? Why we haven't mentioned this ID is unique? Because we haven't mentioned in our Hibernate part table. It is this is just an ID, but we haven't represented like how to what you call auto generate. So what happens, whatever you entered is going to use it. So earlier we entered 1 2 3 as different values, monitor, keyboard, mouse. Now we entered 1 2 3 places, headphone, charger, case. So those all values has been updated. So you need to use 4 5 6 7 kind of thing, so that all the products will be there. Okay, that's a one-to-many relationship. Same thing, all you need to do is go back and look at how to configure many-to-one relationship and many-to-many relationship. Okay, can you consider as an assignment for many-to-many, and one-to-many is like more or less reverse criteria. One-to-one, you can look at it, right? So can you guys go back and take it as an assignment so that we save some time for me? Okay, so how do I understand what are the configurations I need to do kind of thing? You go back all the end of the page, look at the references I mentioned, how to represent the collections. Okay, good. Okay, nice. Next one is caching. This is interesting. What to do? If I do another 40 minutes, it will be gone. So, but I want to do end-to-end program. Yeah, let me explain you first what exactly cache and how exactly it is. and then we'll keep this one separate task by end of today, and then I'll do the program as well. If I'm not going to do the program, I'll upload the program at least. Okay, so caching, like I mentioned, right? Caching is you want to cache the data in your application rather than going into the database every time, there are like I mentioned, um, we have millions of records, and if you keep on making a call, the database call is going to be very costly in terms of connectivity, network calls. It needs to go outside of your JVM and establish a connections to the another port where the database is running, and then consistently keep the connections open, because there is a limit for the connections, like there are 200 or 300 connections max you can provide. Otherwise, once it reaches, like other CPU uses will increases, and network uses will increase, so it will go out of your control. So the network connections you need to use as minimum as you want, as you can. So for that reason, in order to reduce the database calls, caching comes into picture, which means certain data you can cache it in your Java code in JVM itself, so that you can serve the data from your JVM rather than going back to the database. Okay. Okay. Um, there are two types of cachings in Java. I mean, Hibernate level, what do you call first level caching, second level caching. What is first level caching? Whatever we're doing as of today is a first level caching. Whatever it loads in the session, whatever it loads at session level, it will be cached, so it will be available for you. Okay, so basically in your session factory you have multiple sessions, right? S1, S2, S3. Whatever it caches, right? Whenever you call in that session, whenever you get call or session, the data will be cached here until that session is destroyed. S1 dot close, until you call S1 dot close, the session will be destroyed. So that whatever we already doing this part, right? But this is called first level caching. Okay. What if you want to achieve? So you called in this session and you want to use this data in another session as well. So how can you achieve? You need to take out and keep it outside of your session, right? Whatever the data that you captured, you should not keep it within that session. You need to keep outside of the session, so that if some other session want, they can access the data from there, right? Outside of the session keeping is nothing but keeping it in session factory. Keeping it in session factory. That is nothing but level 2 or second level caching. Okay. Whatever we do at session factory level is nothing but second level caching. Whatever we do at session level is nothing but first level caching. Okay. So the second level caching, like I mentioned here, once you keep it in session factory level, anybody can access, right? Which means entire application. So which means it's available for across application, right? Because you establish everything from the session factory, right? So if you keep something in the session factory, everything will be available. Everybody can access that. So second level caching is nothing but per application. Enable second level cache. Configured cache factory class. You need to configure this separately and define what there are different types of cachings. Okay, there are different type of cachings that Hibernate provides. I mean, third parties also can integrate with Hibernate. Third parties also can integrate with Hibernate, so that caching mechanism can be used with the help of Hibernate to support your uh, caching mechanism. Okay, one of such mechanism is EH cache. Okay, configuring EH cache, define EH cache and configure your, define how the EH cache should be, and then you need to bring that EH cache definitions into your configuration file and configure using, you configure cache usage, how to use it in using HBM file. Okay, so what are the different second level? I think I mentioned, no? Thought I mentioned somewhere. There is somewhere, it will be there. I should have mentioned that. So I thought I mentioned this. Yeah, this guy is having. So there are different types of caching mechanisms are there. If you use EH cache, how it works. If you use OS cache, how it works. If you use warm cache, how it works. JBoss. Okay, I'm going to explain you guys about EH cache. This is popular, which is very well fit with Hibernate. Okay, so there are different type of, you can also write your own caching mechanism and you can integrate with Hibernate. Caching is nothing but how you can store in your application, which will be available across as long as the application is running, and which will be, should not run out of memory, which will smartly detect which calls need to cache, kind of thing. Okay, so first thing is you need to configure the EH caches. First thing is different type. This is the EH cache that is available. This is the EH cache that is available, and this is the EH cache Hibernate integration. This is EH cache Hibernate integration configuring. Okay, so that first, if this will be downloaded, and then Hibernate EH cache support also will be downloaded. Jar file support will be separated, and then what and all you need to do? All you need to do is you need to configure all these things in your configuration file. What you need to do? You need to convey in your configuration file. Second level caching I am enabling. You need to convey I am enabling second level cache, and then is it a query cache, which means do you want me to cache all the results of the query, and then what is the caching technique class that you are using. EH cache registry region factory, and then where is that cache definition. You need to write another XML file where your cache is going to have ehcache.xml. Okay, Then what and all are you going to configure in ehcache.xml? See here. This is the ehcache DTD configuration namespace, and then you need to convey, like, okay, update of the cache is automatically allowed, and monitoring is auto detect. You go, you're conveying ehcache to say you identify and then cache it. Okay, and then if, let's say, if your RAM runs out of memory, then how do you want to store? Where do you want to, like, you need to write somewhere in hard disk, right? If you what I'm trying to say is, like, you have a 2 GB of memory, and you give 500 MB of memory to RAM memory to your caching technique. So what if 501, once 500 has been filled in cache, what if 501 MB of memory comes into? You shouldn't throw. Instead of throwing out of memory, we are conveying, go ahead and use my hard disk and cache it there and keep writing data there and make use of that my hard disk as well. That is what you are doing. And then what are the default techniques that you want to use? The default cache, maximum entry in local heap, how much time you want to keep it, how much time, let's say you cached a record, and do you want me to keep the record all the day? Do you want me to keep release this record if nobody uses this record? So do you want me to delete it? If you want to delete it, how often I need to do it? Either 2 hours, all these things. Time to idle seconds. Okay, time to leave seconds, and then all these configurations. What is the size, and disk connection expiry, what happens, you need to do what you need to do. What is the algorithm I need to use, least recently used LRU algorithm. So you can define that. Okay, and then what and all you want to cache. Now I am asking to cache credit card payment. I am asking to cache credit card payment. Where do what you call it? How much time? 60 seconds. After 60 seconds, release it. Okay, where do you want to store it? Use a local temp swap. Okay, and then same, you need to convey what kind of caching you want. You want credit card payment, I understand. When do you want standard query caching? I want to cache whenever you query to the database, go ahead and cache. Those kind of definitions you will provide here. And then update timestamp for cache. What is this purpose? I don't remember exactly. If you look at, you can easily understand what exactly this means. I totally forgot about it. Okay. So this thing you need to configure again in your what you called in your XML file. Then uh, yep, that's it. When you try to access right now, when you try to access it, automatically, oh yeah, you need to configure this thing in your HBM file. You need to convey, while updating also, do you want to cache? While inserting also you want to cache, or just reading you need to cache? What kind of caching you want, you need to convey. This student caching, what level you want, just read only cache you want, or update cache you want, kind of thing. Okay. Mm, what else is there? Yeah, try out. It's not a big deal. understanding the concept is important, and the configuration will be the same. This H cache definitions, maybe you'll change the numbers, how much time and local heap time, these kind of things you will change. The remaining part will be same as is. Okay, same in case of here you don't change anything, you just conveyed in your configuration file. I'm going to use H caching in your configuration file, and you are defining H cache, how it's supposed to act, and in your mapping file, if you are loading student, what kind of caching you want, whether you want to read only and write or kind of things. Okay, make sense? Yeah, that's it about second level caching. um, but it's very important questions for interview. Everybody will ask, like, can you explain second level caching? How do you achieve using section factory? What kind of second level cachings are available? There are different kind of available. The best fit would be EH cache. How do we integrate EH cache with Hibernate configuration? You need to convey in your configuration file that you are using second level caching, and then that your query caching you are using, and you need to provide your H caching configuration, and in H configuration you need to write all the configuration definitions, like what is the default cache, and what kind of cache you want, like you want to create what kind of objects you want to cache, you need to configure those, and what kind of caching you want, query cache you want or different cache you want. So you need to mention that. And then in your Hibernate mapping file, you need to convey what level of caching you want. Is it a read only or read write? If you always if you search for this, you can get different options. I configured read only, right? You can get read write and write, all the options. Okay, so that's how you configure second level caching. Okay, awesome. So take a break for 10 minutes. I'll send you another invite in a couple of minutes. In 15 minutes, we'll start another session. Maybe 11:30 we'll start another session. Okay, where we're going to do all the end-to-end integration. Okay, thanks guys. In 15 minutes, we'll start another session.